Hi, are you good at solving puzzles? Are you good at finding the right information to reach the correct answer? Here we have a collection of 10 where you must look at the information very carefully. Let's have a go. In this first one, who's that? The aim is to find out from the information who is in the framed picture. Now, what we have is Joe, who is looking at the painting, and he says, "Brothers and sisters I have none, but this man's father is my father's son." Who is he talking about? If we look at the part about my father's son, that could be referring to Joe. Can it also refer to his brother? No, because it says it as part of the information he doesn't have any brothers. So my father's son is Joe. The next bit of information, this man's father. That means the father of the person in the photograph or the painting is Joe. Can you see who it must be? Yes, I think you have it. It must be Joe's son, because the father of Joe's son is Joe, isn't it? All right, let's move on to the next one. Let's read it out. Whose farm to use? Farmer John and Farmer Jim share a common fence. Exactly on that fence is a tall tree on which squirrels live happily. One day a storm shakes the tree and, unfortunately, some squirrels fall to the ground, with all but 4 surviving. On which side of the fence should the surviving animals be buried? It's a sad situation, isn't it? We have squirrels that have fallen and some of them haven't survived, and we want to know, should the survivors be buried on Farmer John's side of the fence or Farmer Jim's? What do you think? Can you see what's given it away? Surviving animals. What does that mean? Surviving animals, of course, means the animals that haven't died. So it would be silly to bury them, wouldn't it? So our answer must be that you do not bury survivors. Let's move on. Here we have a picture of a train. A diesel train, it says, leaves the town of Happyville, heads northeast, and then soon reaches a speed of 80 kilometres per hour. At the same time as the train is moving, there is a westerly wind blowing. In which direction will the smoke of the train be moving? Sounds like a complicated mathematics question, doesn't it? Because we have the wind coming from one direction and smoke from the train moving northeast. How would you try this one? Can you see the important part of it? A diesel train. Do you know what a diesel train is? Is it a steam-driven train? No. A diesel train runs on diesel fuel, just like a normal car engine. Therefore, there is no smoke. Therefore, we cannot say in which direction the smoke is moving because there is no smoke to begin with. What about this one? Where does the egg fall? We have a rooster who flies to the top of a sloping roof and lays an egg. So here we go. There's our rooster. There's the top of the sloping roof right there and lays an egg. Now, if the egg is exactly on the top and it's precariously balanced, that means any touch of wind will blow it. On which side do you think it's more likely to fall, given the shape of the egg, which is oval? Would it fall towards that side or towards that side of the roof? What do you think? Again, can you see the important word here? A rooster. What can we say about roosters? What do we know about roosters? What's the difference between a rooster and a hen? Hens lay eggs. What about roosters? Do they lay eggs? Of course not. Roosters do not lay eggs, but hens lay eggs. All right. Have I tricked all of you so far? Let's move on. Which direction? Here we have a globe of our Earth. Where on Earth should you stand so that you're always going to be moving due south? Where exactly would you have to be on the Earth's surface so that No matter what direction you start at, it will always end up making you go due south. Are you familiar with meridians of longitude? What do they look like? Here's our globe. They're lines like this, aren't they? Imaginary lines, of course, but they tell us the position on Earth. What if I was standing exactly on the top here? Very, very small, of course, I would be. That means I'm due north. If I move in any direction compared to the Earth's surface, I would be moving this way, wouldn't I? Can you see that? It doesn't matter which way it seems like I'm starting, it's always going to end up showing me moving due south. So the answer would have to be that you must be exactly at the North Pole. Here we have another image of our Earth. Now here, let's suppose, this is all imaginary of course, because physically this would not be possible. Let's suppose we have somehow a hole big enough from one end of the Earth, let's say starting here at the top, all the way through the centre and out the other end. And we jump in, let's say from here. At what speed will we end up at the other end of the tunnel, I guess you could think of it as? Can you see what would happen? Now we're going to ignore the obvious things. You would be probably melted to death before you even got a fraction of the way through. Air resistance we ignore, and so on. What would be your speed? Well, what we do know is that as you're falling through, the greatest gravitational force is at the centre of the Earth, isn't it? So from the top, your speed will be increasing until you get to the centre, and then what happens after that? Then as you move towards the other end, your speed would decrease gradually. And then finally, as you get just to the end there, what would be the speed? Well, the speed originally up here at the top was 0, wasn't it? Because you jumped in. You didn't jump in with an initial speed, you just sort of fell in. Let's look at it that way. So that means at the other end, as you're slowing down, just as you get to the end, your speed would match your original speed, which of course would be 0. You're not moving at all. All right, you might have seen variations of this idea. Tim and Bjorn are digging holes, each of depth 60 centimetres, that they use to hold fence posts. It takes Tim 20 minutes to dig one of these holes, but Bjorn takes 22 minutes. That means 2 minutes longer. Now, suppose they both start at the same time to dig a hole. Who will be the fastest to dig half a hole? What do you think? 60 centimetre hole? Half a hole? Is that 30 centimetres deep? Well, if we go by that, then for half a hole, Tim would take 10 minutes, wouldn't he? And Bjorn would take 11 minutes. And Bjorn would take 11 minutes. That way you would say Tim is the fastest. If we interpret the information, what do you think half a hole looks like? A bit strange? Can we physically see half a hole? We know what a hole looks like. It's a cavity, isn't it? That doesn't have anything in it, obviously. Can we have half a hole, half a cavity? Not really. We can look at the depth of a hole, but we can't refer to something as being half a hole. So again, the question is not appropriate. Let's see if we can find the contradiction in this statement. I'd give my right arm to be ambidextrous. I guess to understand the contradiction in this statement, we have to understand what that word means. Do you know what being ambidextrous means? Perhaps this will give you an idea. It means you can do things equally well with using both your left hand and your right hand. For example, some people can write just as well using their right hand and their left hand. So I guess this is a sort of joke that you would give your right arm to be ambidextrous. Well, you need 2 arms or 2 hands to be ambidextrous, don't you? So giving up one arm cannot make you ambidextrous. This one is probably a bit more challenging. Here we have a father and a mother, and they are in a hospital room. The surgeon says that medical ethics forbids operating on a family member. The father and mother now leave the room, and the room is now completely empty. There's no other way out of the room, and the only people that have left the room were the father and the mother. So what happened to the surgeon? Did he disappear in a puff of smoke? Did he crawl behind the couch and hide? No. We know what a surgeon is, don't we? A professional that operates. They can be male or female. What did we assume in this question? We assumed that neither the father nor the mother was the surgeon. But isn't that possible? A surgeon can be either male or female, and I'm sure there are surgeons that are either mothers or fathers of people. So what can we conclude? That one of the two people that exited the room, either the father or the mother, was the surgeon. So the scenario, I guess, would have been that inside the room, if the father was the surgeon, the father would have said to the mother that he cannot operate on the patient, which is probably another member of the family. Similarly, if the mother was the surgeon, the same situation would apply. Here we go, loss in the forest. Let's say you are in the middle of a forest. You don't have a compass, which is always a useful thing to have, but in this case that won't matter, because you know that if you walk in a straight line in any direction from where you started, it's guaranteed that you will reach the exit taking the same amount of time. Can you explain how this can be possible? You're in the middle of the forest. You don't know which direction north is, or south, east or west. But you do know that if you just walk in a straight line for a certain amount of time, you will end up being out of the forest. I guess the thing to keep in mind is that you are in the middle of a forest. Can you think of some simple geometrical shapes that refer to the middle? I think you might have hit on it. What about circles? The middle of a circle? Do we know anything about the distance from the middle of a circle to the end, or to the circumference of the circle, as we say? It's always the same, isn't it? It's called the radius. And there we have it. If we assume that the forest has exactly a circular shape and you are exactly in the middle of it, doesn't matter which direction you take, as long as you go in a straight line, you're guaranteed to reach the edge of it.